So today we're learning about topographic maps and satellite images. So these are just ways to visualize different land features. So this is a topographic map of a bend in Marsh Creek, and then this is another one, but a satellite image. These tell you different things. So you can tell vegetation much easier on a satellite image. But a topographic map, you can determine the contour or the shape of the land much better. So if you look at these little contour lines, you'll notice that it's really steep right here. And this is going to be an area of high erosion. You can kind of see that here, but not as dramatically as you can on a topographic map. And you can see like there's a little railroad going through here. You can see that railroad going through as well. You can see the creek. You can kind of see or imagine where the creek might be on here. So you can kind of get an idea of the land features. When you're reading a topographic map, they're designed to give you a two-dimensional view of a 3D surface. So contour lines are lines that connect points of equal elevation. So everywhere along one contour line are equal elevation. Contour interval is the difference between elevation between lines. So for example, most contour interval is going to be given to you and it's going to let you know. The index contour is typically every fifth line, and it's drawn a little heavier, and you can kind of see how this line's drawn heavier. And then there's little light ones, and then there's another one that's heavy. There's light ones, and then there's another one that's heavier drawn. And that just gives you a point of reference to determine different elevations. If you see V shapes like you do here, that is usually letting you know that the V's pointing uphill to the start of the stream. Narrow V's are letting you know that waters are fast moving and they're carrying sediment downhill. And then your wider V's are indicating wider, slower moving waters that will deposit sediment as the water flows downhill. Something else to look for is where the lines are close together. When the lines are really close together, it's going to let you know it's steeper, and it's probably going to erode more when the lines are close together at areas of steepness. So if lines are a closed loop like this, smaller circles indicate less eroded hilltops. Widely spaced contour lines indicate gradual slopes. So like here, it's gradually increasing in elevation. If the lines are really close together, like here, it's letting you know it's a steeper slope. So satellite images can record the effects of weathering, erosion, and deposition over time. Alluvial fans are fan-shaped deposits of sediment, and you can kind of see it right there. It kind of creates a fan. Scientists monitor alluvial fans to understand their change over time, and it's just the deposit of sediment. Another thing you can use satellite images for is you can actually see ice breaking off the Petermann Glacier in the Arctic on here, and they can monitor that over time without ever actually going there. And scientists monitor glacial erosion and size of glaciers to understand what may be happening to glaciers in the region because of global warming or climate change. The Mississippi River Delta is formed by sediment carried by the river. So this is a delta right in the Gulf of Mexico, where at the mouth of the river, where the river is meeting the Gulf. And so this is just where all the sediment gets deposited. This is Enchanted Rock, which is basically a big hill down near Austin, and it's in a state park called Enchanted Rock State Park. And then you can see it on a topographic map. It's kind of like this big dome rock, and you can see how these lines actually make that dome. So that was your review on topographic maps and satellite images.